Robotics is a branch of science and engineering that focuses on the design, construction, operation, and programming of robots. It combines different areas of study, such as mechanics, electronics, and computer science, to create machines that can perform specific tasks.
Lesson 1: LEDs. The first activity is blinking LED. In this activity, a small light turns on and off repeatedly using a microcontroller. The microcontroller sends electrical signals to the LED, telling it when to turn on and when to turn off. When the signal is high, electricity flows through the LED and it lights up, and when the signal is low, the flow of electricity stops and the LED turns off. Second activity is fading LED. A LED slowly increasing and decreasing the brightness of a light using a microcontroller. The microcontroller controls how much power goes to the LED by sending signals at different levels, making the light appear to fade in and out smoothly. The third activity is alternating blinking LED. Two or more LEDs light up one after another in a repeating pattern. When one LED is on, the other is off, and then they switch. This happens because the microcontroller sends signals to each LED at different times, creating a blinking effect that looks like the lights are taking turns. The fourth activity is the button-controlled LED. By using a button as an input to control the light, when the button is pressed, the microcontroller detects the signal and turns the LED on. And when the button is released, it turns the LED off. Last and the fifth activity is the LED brightness using a potentiometer. By using a potentiometer, the microcontroller reads the potentiometer's value through an analog input pin and then adjusts the LED's brightness based on the value. Turning the knob one way makes the LED brighter, while turning it the other way makes it dimmer. Two LED tasks. The first one is the dancing light. This is controlled by a microcontroller which sends signals to each LED one after another, with short delays in between. The sequence can be programmed in many ways. For example, lights can blink from left to right, back and forth, or in random patterns. Second LED task is the traffic light simulation. Using LEDs and a microcontroller, in this setup, 3 LEDs, red, yellow, and green, represent the lights used at road intersections. The microcontroller controls when each LED turns on and off, following the correct traffic sequence: green for go, yellow for slow down, and red for stop. Each light stays on for a specific time, controlled by programmed delays or timers. The second lesson is all about buzzers. The first activity is the buzzer beep on button press. With this activity, The buzzer is expected to make a sound or alarm when the button is pressed. The placement of the wires and the code that is used is what makes it possible for the project or activity to work. The second activity is the melody player with buzzer. In this activity, the buzzer is programmed to play a tune or melody with the help of the code encoded into the PC. The third activity is SOS mode with a buzzer. The purpose of the construction of this activity is to use the buzzer as a medium to send signals and emergency alerts. The fourth activity is the light-sensitive buzzer alarm. In this activity, the buzzer would not alarm or turn off when light is detected by the LDR or the light-dependent resistor. The resistance of the LDR depends on the light intensity that the component is receiving. The last activity is the buzzer controlled by potentiometer. A buzzer controlled by a potentiometer is a simple electronic circuit that allows you to control the frequency and volume of the buzzer. The potentiometer acts as a voltage divider. The voltage is the output of the potentiometer that is used. There are also two buzzer tasks. The first one is the custom melody challenge. The microcontroller sends different frequency or tones to the buzzer, and each frequency represents a musical note. By carefully timing each note and pause, the microcontroller can play the full melody of the happy birthday song. The second task on buzzers is the multi-Morse code transmitter. A buzzer sends messages in Morse code, which is a system of dots and dashes, representing letters and numbers. In this project, a microcontroller controls how the lights or sounds turn on and off to form these signals. The last lesson or the lesson 3 is the 7-segment display. The first activity is displaying a single digit on a 7-segment display. Displaying a single digit on a 7-segment display involves understanding how the display works and mapping digits to their corresponding segment patterns. How does a 7-segment display work? A 7-segment display consists of 7 LEDs from letters A to G, arranged to form digits from 0 to 9. Each segment can be turned on or off to display different digits. The second activity is displaying numbers from 0 to 9 sequentially. This activity involves programming a microcontroller like an Arduino to display numbers 0 through 9 sequentially on a display device, such as a 7-segment display. This is a fundamental exercise in robotics and embedded systems, teaching basic programming concepts and hardware interfacing. There are two tasks under the 7-segment display. The first one is the countdown timer with blinking 0.
Ang gara mo. Ang gara mo. Napakagara mo. Ayun! Yun! Ayun! 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 Ayun!